All right, this is technically logs day 3. And what we do in logs day 3 is you learn how to solve equations where the x is in various spots. You need to put the x there, or you can put the x here, or you can put the x here. There's those 3 spots where x can be. And you learn how to solve it in any of those 3 situations. Okay? Let's just tackle that right off. If I wanted to solve this one, I would do a rewrite. If I wanted to do this one, I would do a rewrite. Rewriting is obviously important then. Rewriting is where you go like this. 12 equals 2. X, that's a weird way to write an x, to the 12 equals 2. Okay? And how do I solve that? You just put it to the power of 1/12. And would you have a calculator for that kind of a problem? Yes, you'd say to the power of 1/12 on a calculator. Now, a lot of the ones we're going to do will have fraction exponents like that, but they'll be doable without a calculator. Like, for instance, on your iPad, would you please write this one down? Log base x of 3 equals 3. We'll solve that one. Well, you'll have x to the 3rd equals 3 if you're doing it right. And that seems simple, but it's really not that simple. Why? What's my next step? Yes? Put them to the 1/3 power. Okay. And that seems, again, fairly simple, but this one equals 3 to the 1/3. It's not just 1, because 1 times 1 times 1 isn't 3. And it's not 1.3 repeating, because that would just be taking 3 and dividing it. You'd have to use a calculator, realistically, on this one. Okay, so what numbers can we take the 1/3? The 3rd root of 9? No, because 2 isn't 9. 27? 27 we could do? What else could we do? It'd have been 8. Could you have done that? Sure. How about 1? Because what's the answer to that one, by the way? 1. Because 1 times 1 times 1 is 1. So, how about the biggest one of all that I'll ever ask you? Well, actually, there's 2 more. Nope. Don't have the cube root of 81. 64. What's that? Cube root of 64 is 4. 4 times 4 is 16. 16 times 4 is 64. And then the last one I would expect, the biggest one I would expect, 125. Very good. All right. So if I had put that number right here, then that one would have been a more reasonable question for you to be doing in your head. All right. So you'd have x to the 3rd equals 125. You put them to the 1/3 power. Okay. Now, I have one to stretch your mind a little bit. Let's say that's 2. That's a 25. Try that one. It's going to seem really easy to you. And I'm going to guess only 2 people in this room will get it right. All right. Raise your hand if you're thinking you got it. Now, you know when I said that it was, kind of hard, that there must be some kind of a twist to it. Some of you caught a twist, and then maybe you didn't really catch the twist. We'll find out. How many think you got it? Raise your hand if you think you got it. Be confident now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So, show your answer to somebody else so you can verify later that this is what you actually said it was. Okay, just show it to somebody else and see. Make sure somebody saw your answer. Don't be shy. Say, here, look at my answer. You haven't seen anybody look at yours yet. Okay, here's the most common way to do this. People go, okay, x to the second equals 25. Wait a minute, this must be harder than that because the answer just seems like it's 5. And then you go, okay, to the power of what, half. This is really taking a square root. And did anybody remember that you were taking a square root and therefore you need the absolute value, and therefore you need to have answers, x equals 5 and x equals negative 5. Raise your hand if you remember that. Okay, but the problem is you're wrong. Ha! It's a double twist. That's the first twist. The next twist is, do you remember that when you're all done, you're supposed to check and see which answer really works? The negative 5, even though you must identify it is an answer, is an extraneous answer, because if you put it there, you'll have a negative, and that's not allowed. So you'd have to have said this, that the answer is negative 5, but negative 5 is extraneous. Who actually said that? Nobody. Okay, I thought it'd be tough to get even a couple of people to get it right. All right, so if you just said 5, you'd sort of be right. But it's like you're right only because you were ignorant, because you didn't think about the fact that it should be negative 5 also, and then rule it out because it's extraneous. You know what I'm saying? I mean, just you missed the whole step doesn't mean you're a genius. All right. So that's a tough one, I know, and you can feel good that many other really smart kids didn't figure it out either. Okay. So final answer is. But you should also have identified that negative 5 was an extraneous answer. All right, let's do another one like that. All right. You should have said x squared equals 16, and this is eerily similar to last time. And therefore, when I think x equals 4, and wrong, what am I forgetting? Absolute value, and then I split it into 2, x equals 4, and x equals negative 4, and then, wait a minute, you can't have a negative, so therefore that's out. The answer is 4, and this is also an answer, but an extraneous answer. Raise your hand if you have both of those. Good. All right. What if I had changed one little thing? 4. Sorry, this 2 into a. Could you have done the 4th root of 16? Try it. I don't know if you know what to do with that whole negative thing. Do you still have to worry about that or not? Or so just set it up and see if you think there should be a negative answer, or should there not be a negative answer? Or should there be a negative answer that is extraneous? All right, you should be saying x to the 4th equals 16. Put it to the 1/4. So, wait a minute. Do I have to do that absolute value thing in this situation? Yes, you do. Because it's an even number, yes. If it's an even root, like a 2, a 4, a 6, or an 8, you have to do the absolute value thing. So it's the absolute value of x equals 2, and then there's therefore two answers, x equals 2 and x equals negative 2, and therefore that negative 2 gets thrown out because you can't have a negative in that position. Where's the other? You can't have a negative right there. Can't have negatives in either of those spots. Can have a negative over here. That's allowed. Yes, neg, no neg, and also no neg. You also can't even have zeros here or here. It'll mess things up. It'll make things impossible. Okay, so we've learned something. There's 3 spots where the x can be, though, and here's the next spot. Log base of x equals 12. This is much easier because it's done as soon as you rewrite it. Mr. F, would you rewrite this for me? Equals. See, it's done. X is alone. As soon as x is alone, you're done. And then 2 to the 12th, well, yeah, it's going to be a pain in the butt to multiply up, but it's a doable problem. All right, so this kind, as soon as you rewrite it, poof, the x is alone, and that's all you want. And then the last kind is where the x is in the other spot. Log base 2 of 12 equals x. And that's awesome because it's already solved. What do I mean? The x is alone. So the answer is log base 2 of 12. So either you can do it in your head, or you can do it with a calculator, or you can estimate it. See, you can't do this one in your head because you don't know 2 to the what power 12 in your head. It's not going to be a nice one. But you can estimate it. I would like you to estimate it. You got pretty good at estimating yesterday. We'll see who gets the closest. And no using a calculator, of course. And then we will check it with the calculator, and whoever is the closest will earn a small prize. 2 decimal places. No checking it with the calculator. That would be cheating just to get a small reward. Not worth it. You're looking very sharp today. What's the situation? Just looking sharp. All right. Way to go. I thought there was a chance you were like you had a meet after school today or something. All right. I know you know it's not 1. And 2 would be too small also. 3 is still too small. 4 would be a little bit too big. All right, so show your answer to somebody else so you can prove later what you thought it was. All right, now do a log. Figure it out with a log. Log 12 over log 2. What do you get? With a calculator. What was it? 3.58. Who had 3.58 exactly? You had it exactly? Very impressive. All right. Exactly? Did you show anybody? All right. Come on up. Grab from my bag of mystery and wonder. Okay. So now, let's do a little quick review of the stuff that's on that Schoology quiz before you take it, because this is a Schoology quiz where you only get 1 shot at it. As in, it's like 6 questions, and you have to, if you get a 4 out of 6, you're stuck with it. So it is not timed. You do have to do it during this class period, though. No calculators allowed. All right. So now, don't start it. Don't open it. In fact, shut your iPads for a minute. I want to make sure nobody's actually doing the questions as I show you how to do them. All right. So here is a little quick review. You learned some properties that make these way fast to do, like what's the answer to that? 2. Because if this and this are the same, then the answer is the exponent. And the reason why is because if I set this equal to x, I can go 2 to the x equals 3 to the 3 to the x equals 3 to the second. And that makes total sense then that x must be 2. Okay, how about this one? Log base 17 of 17. But it has no exponent. But the exponent therefore is a 1, and therefore the answer is 1. Okay, how about this one? Log base 17 of 0, automatically. Know why? Because if I rewrite this and I put an x over here, you can always do that if you want. 17 to the x equals 1. Think about it. 17 to the what would equal 1? 0. That's why the answer is always 0. Okay, next kind. Let's say we had a 12 to the power of 17. 17. Because if this and this are the same, that's the answer. Now, why? Why? Because, and this is a good statement, the person who knows what the answer is will usually have a job. But they will be working for the person that knows why. So let's see why. Why is this going to work? This is a hard one. Do you get that this is an exponential? It's not a log. You're like, what do you mean? There's a log in it? It's not a log. It's not. Why isn't it a log? Because there's a base and then something to a power. Do you get how that's really an exponential? So if that's an exponential, you could rewrite it as a log. So I'd start by saying log, and then what would I say for the base? Base 12. And then where do I go next to get the next part? Over here. You always go to the other side to get the next part. And then it will equal all of that stuff. Now, do you get that x is 17? All right, another way to think of it is, if this is log base 12 of something, is log base 12 of 17, the only difference between these two is this is an x and this is 17, and therefore this must be a 17. Okay, all right, so the answer is 17, and it'll always work if this and this are the same. That's the answer. Okay, that's a little review that should help you on that Schoology quiz. Well, that's fresh in your mind. You might want to go take the Schoology quiz. And when you're done with that, the homework is there, and I think you'll find it's not too bad. Some kids finished in class today. So get cranking on your Schoology quiz and then start your homework. Got a question? You are correct. The one on Skyward is not to be taken yet. Do the one on Schoology. Just Schoology one. The Skyward one I'm actually giving you tomorrow. You want to do the Schoology one because I just got you ready for that one. The Skyward one I'll get you ready for before we take that. Tomorrow. Okay, that's all the video I got for today. Actually, I'm gonna pause for just a second. When we start the homework, I might do another problem or two with you. Okay, I'm back recording again. I am looking at the beginning of the worksheet, and this first one is pretty much a no-brainer. You just have to multiply these two, because power to a power, you just multiply. And so then these threes just cancel, and it's 8 over 4, and I can reduce that. What's 8 over 4? 2. Done. All right. Let's move on and look at a harder one. Let's say you had here. This is a square root. It doesn't mean square root. It means you take the square root and then you flip. You guys are both looking at something that you should not be looking at right now. Make sure you look at math for now. Questions? Yes? Well, yeah, I'm sorry, I didn't ever finish this thing. So this cancels this, and this turns into a 2, but then what is 9 squared? It does say evaluate, which means get the answer. Okay, so yes, final answer, 9 squared, 81. Anyway, this one, the square root part, and then flip it. So we square both this. Pretty. Okay, questions on that? All right, hang on. Here, that one looks different. 2/3 to the x equals 8/27. That's not going to solve any easier. Sometimes you rewrite them and you realize that was dumb. That doesn't help. I guess I should leave it alone. But then I must fix this somehow so it has a base of 2/3. Can I rewrite 8/27 as 2/3 to the something? I could. I'd know what the answer was, right? Because then this and this would be the same. All right, so 2/3 to the what? I need it to get bigger, so it must be like to the second or the third power, and ooh, it's the third power. And then, am I done? Is that it? All right, so if this 2/3 to the third is the same as 8/27, I'm just double checking that, yes it is, then I now have log base 2/3 of 2/3 to the 3, and then when you got it rewritten like that, the cool thing is the answer is just sitting right there, like an apple on a tree wanting to be picked. There it is. Okay, moving on to number 2. Please, 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 after all I showed you, don't forget the whole absolute value thing. And when you get to pre-calc, you can be that one kid that never gets that problem wrong on the 4 tests where you're going to see it. And you have square root of both sides, and you have absolute value of x equals 5. And then you split that into plus and minus 5. X equals 5, x equals minus 5. And this time it's not even extraneous because it doesn't have context of x is like the little number log. So both answers are necessary. 5, negative 5. Get what I'm saying? You got to have that value there. The only reason it was extra 4 is because it was in a log problem, and if the x is down here, it can't be negative. Or if the x is there, it can't be negative. Yes? Did you get me on attendance? Did I? I'll talk to you about that later. I might have already taken it off the check. All right. I know I took it recently, but it might have been the very end of last time. I can see what I'm thinking of. All right, so let's move on and find some other ones that are harder to solve. How about this B? That says x to the negative 1 equals 15. How do I fix that? All I got to do is put it in the power. The power is negative 1. Why not just power of 1? Because when you put something to the power of 1, nothing changes at all. But if I put it to the power of negative 1, now the two negatives will cancel each other. Oh, my computer is frying out here. Seems like probably a good time to stop because I can't write on the board anymore. So, I guess that's the end of my lesson for today. Why did that disappear? That doesn't normally disappear. And now it's still recording. I'm going to stop now. It's still recording. The lesson that wouldn't stop.